Imagine plugging a massive new engine into your company's network, but having no idea where its fuel is coming from. Right now, over 62% of enterprise staff are operating completely blind to their organization's actual AI data flows. The lack of visibility extends all the way to the top. The majority of high-level executives do not know exactly which AI models are actively running inside their systems, let alone what specific internal data is being used to train them. In a strict business-to-business environment, this lack of traceability creates a critical vulnerability. If you cannot trace where the data originates, defending against a semantic prompt injection, a technique where a user disguises malicious instructions as normal text to manipulate an AI, becomes mathematically impossible. Rushing to deploy these large language models, or LLMs, without absolute source visibility is the blind accumulation of systemic business risk. To fix this blind spot, organizations must merge traditional data security posture management with a dedicated AI security posture management framework. This combination allows security teams to dynamically track data as it moves across complex, multi-cloud environments. This level of tracking requires a specific piece of infrastructure, the AI BOM, or AI Bill of Materials. It serves as an exhaustive, mandatory catalog of every component inside your AI system. Think of your enterprise AI as a massive commercial kitchen. The training data, the model weights, and the open-source dependencies are your raw ingredients. As a business owner, you would never serve food without verifying exactly which farm those ingredients came from and whether they passed inspection. If an AI model suddenly outputs highly sensitive financial data or generates a severe hallucination that costs a client millions, you need to find the source. Without the precise catalog provided by an AI BOM, you cannot trace the failure back to the specific corrupted batch of data. Implementing an AI BOM forces a necessary structural correction. It turns a dangerous black box operational liability into a transparent, strictly managed corporate supply chain. Securing the source ingredients handles the preparation phase. The real danger occurs during inference, the live operational phase where the AI actively processes user prompts in real time. Traditional firewalls block threats by looking at IP addresses or packet traits, which fails against conversational AI. Instead, you need a double-agent semantic firewall. This system reads the underlying intent of the natural language being submitted. This diagram shows how the dual-interception process works. On the left, an independent agent intercepts the incoming user prompt, screening it to see if it contains a disguised malicious command. On the right, before the AI's answer reaches the user, a second agent intercepts the output, ensuring no sensitive corporate data is accidentally leaking out. This interception is especially critical in RAG, or Retrieval Augmented Generation architectures, where the AI looks up external company files to help answer a question. Because these vector databases search by mathematical concept similarity rather than exact keywords, a vague question from a junior employee might cause the AI to fetch an unauthorized financial document simply because the math aligns. To prevent this, system architects bind employee identity and access rights directly onto the physical mathematical vectors as metadata. Think of this metadata as a mandatory passport visa. Before the AI can retrieve a piece of data, the system verifies the user's visa. If the employee's security clearance doesn't match the tag, the file becomes mathematically invisible to the AI. Strict metadata tagging creates a definitive physical layer blockade against unauthorized retrieval. Even with strong firewalls, there is a massive operational flaw in how most companies deploy AI. To keep the model from misbehaving, developers force the system to read a long, redundant list of security rules at the start of every single user interaction. AI models charge by the token, which is roughly equivalent to a piece of a word. Forcing the system to process the exact same safety instructions for thousands of employees all day long creates a punitive token tax. This repetition scales exponentially, draining cloud computing budgets by the hour. The solution to this redundancy is an architectural breakthrough known as SysVec, short for system vector. Instead of feeding the AI a block of text to read over and over, SysVec compiles these rules into a hidden state representation. It injects the safety parameters directly into the neural network's foundational mathematical weights. By baking the rules directly into the deep hidden layers, the safety constraints become entirely immune to hackers trying to bypass them with clever surface-level prompt injections. The financial payoff is immediate. Eliminating the need to process thousands of words of repetitive safety text shrinks enterprise token consumption by up to 3,000 times. SysVec proves that hardening the deep physical architecture of the model directly generates exponential cost savings. Now, we must zoom out from the core mathematics of a single model to the broader enterprise deployment pipeline, specifically the continuous integration and continuous deployment, or CI/CD pipeline, which is the automated process companies use to update their software. Global regulatory standards like ISO 42001 and the NIST AI Risk Management Framework have set strict new expectations for these pipelines. Securing compliance demands active operational evidence rather than static paperwork from a legal team. True compliance requires active, aggressive defense. Organizations achieve this by mandating continuous red teaming directly inside their automated deployment pipelines. As illustrated here, red teaming acts as an automated squad of internal operatives. They are relentlessly firing extreme, intentionally malicious vectors at the model with every single code update to test the limits of its defenses. Static defense borders are obsolete. Only continuous, automated stress testing ensures an AI system remains impervious to newly engineered threats the moment it goes live. While you lock down your internal data, you also have to look outward. Right now, competitors are deploying their own autonomous agentic AI systems, programs designed to execute complex, multi-step tasks with minimal human intervention. These competitor agents operate entirely outside your traditional network perimeters. They are aggressively scraping the open web, pulling in your public financials, scattered press releases, and detailed technical job descriptions. The chilling reality is that rival AIs possess the semantic reasoning to take those scattered digital fragments and flawlessly piece together your core product strategy for the next quarter, all without ever hacking a firewall. Surviving in this borderless, highly analytical environment requires rethinking what constitutes corporate defense. Implementing an AI bill of materials, and vetting SysVec at the physical layer, and running continuous red teaming builds the ultimate commercial moat. These deep structural defenses provide the unshakable, mathematically verifiable trust required to win and secure massive global contracts.